All right, we're going to go over the derivative review worksheet for chapter 3. And I also want to remind you, don't forget to do problem 31B on section 3.5 because that's going to be on the test. So it says, when is the derivative greater than 0? So first step, take the derivative. Wait, I can't read this. I'm going to have to enlarge it. All right. So the derivative will be 12x cubed minus 60x squared plus 24x plus 96. Factor out of 12. And we're going to do synthetic division. And remember, since we're AB, either 1 or 2 is going to work. 1 doesn't work, so it has to be 2. -3, -6, yup, you got it. So we got 12 times that x minus 2, and then x squared minus 3x minus 4, and that factors some more, x minus 4, x plus 1, and then we make a number line. Don't forget to label your number line. -1, 2, 4. Neither of these will be part of the solution. And so we got plus, minus. And we want greater than 0, so we want the pluses, so between -1 and 2. And then from 4 to infinity. Bam! That's easy. Okay, number 2. I'm going to write the problem. It's just easier to see. Okay, find dy dx, which of course is the derivative. Now, you see a product, use the product rule. Now, on this one right here, I'm going to put a plus sign here, and then I'm going to put a negative here. I mean, you don't have to do that, but then it's just easier to keep track of the negative sign. So, using the product rule, derivative of the first, leave the second one alone, leave the first one alone, derivative of the second. Okay, now the next one, we got to use the product rule also. So, derivative of the first, leave the second one alone, plus leave the first one alone, derivative of the second. And then this next one, if you want to do that as well, now remember that's a constant, so you throw the constant on the side like an unwanted pet, and then you multiply it by the derivative of that, which is negative sine x. And here is, I don't know, it's not supposed to be tricky, but I guess it could be. That is a constant. Sine 2 is a number. So when you take the derivative of a number, you get 0. Don't put cosine 2, it's 0. And then I bet a lot of things cancel out, like 2x cosine x and -2 cosine x. And then, what right here, -2 sine x and +2 sine x. So what's the only thing left? -x squared sine x. Okay, now number 3, very important. These are all definitions of the derivative. Limit as h approaches 0, cotangent x plus h minus cotangent x all over h. That is the definition of the derivative. In fact, what function are you taking the derivative of? Well, you should look there, because what does the definition of, here, let me write it. Here's the definition of the derivative. Limit as h approaches 0, f of x plus h minus f of x all over h. That thing there is the function you're taking the derivative of. So this is simply the derivative of cotangent x, which we know is negative cosecant squared x. Bam, finish. You just look at it and write down the answer. Now b is a little bit different. This is actually back from the last chapter, but it deserves to be here as well. 1 over 3 plus h quantity squared minus 1 over 3 squared all over h. Now, instead of the 3 being here, if you had an x there, then again, isn't that the definition of the derivative? And what function are you taking the derivative of? Well, this, which is of course x to the -2. So the derivative is simply -2x to the -3. But The original problem did not have an x there. It had a 3 there. Which means you need to plug in 3 into the derivative. So what you do is you take the derivative first, which we did, and then you compute the derivative at 3. So if I plug in 3 for x, you're going to get negative 2 times 3 to the negative 3, which of course is negative 2 over 27. So that one's a little bit different. You have to plug in the number into the derivative since that's a number there instead of the x. And then C, this is also another definition of the derivative, which was in your homework, but nobody asked that because probably you guys didn't do the homework at the time. And then when you try to do the homework later, oh, I don't know how to do this problem. Well, this is another, see, this problem here, why don't I just write it here? F prime, the derivative at a particular point is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h, right? That was from last chapter, which was this problem right here, B. But it's also equal to the limit as x approaches a of f of x minus f of a all over x minus a. That was a problem on your homework. They're both equal to f prime of a, the instantaneous rate when x equals a. So when you see this problem right here, you have to be thinking, hey, that is the derivative when x equals 2. But what function are we taking the derivative of? Wait, I have to clear my screen. Something popped up there, and it's not responding. Well, that's why in the problem, it says, if f of x is equal to x to the 5th. Now, of course, you could plug in x to the 5th there and simplify it and to get the limit, but it's a lot easier to recognize that as the definition of the derivative. So what you do is you take the derivative of that, which is 5x to the 4th, and you have to evaluate it when x is 2. That's the number right there. So if I plug in 2 into the derivative, you get 5 times 2 to the 4th, which is 5 times 16, which is 80. Bam. So all 3 of those problems are definitions of the derivative. The last 2, you have to actually plug in the number to get the exact slope. Okay, number 4. Here is the position of a particle moving on a number line. In this case, it's moving on the x-axis. For t is greater than or equal to 0. When is the particle moving to the left? Well, you have to look at the velocity. Well, before you even do this problem on the test, I already told you guys what to do. Find the velocity, which is 3t squared minus 12t plus 9. Factor it. That's a 4 fool. So that's equal to 3t minus 1t minus 3. And then we're going to make a number line for it. And then you find the acceleration. I'm just going to do it right here. Well, if this is the velocity, the acceleration will be 6t minus 12. Factor out a 6. And now let's make the number lines. And again, don't forget to label. So here's the velocity, 1 and 3, plus, minus, plus. And then here's the acceleration, 2 makes it 0, and then plus or minus. Okay, so let's answer the questions. When is the particle moving to the left? When the velocity is negative. Well, here's your velocity number line. When is the velocity negative? Well, you just look at it right there. So between 1 and 3 is your answer. B. Find the total distance traveled by the particle from t is equals 0 to t equals 5. Okay, I'm going to need to make a chart here. So time and position. So we need to figure out the total distance traveled from 0 to 5. So first thing you got to do is you got to figure out what is the position at these 2 time values. Well, if you plug in, here's the position equation. If I plug in 0 for t, you get negative 4. What happens when you plug in 5? Oh my goodness, 125 minus 150 plus 45 minus 4 is a 20. Okay, what is that? Negative 25, 20, 16. So, can I just go, well, if you started at negative 4 and you ended at 16, you move 20 units? No, that's displacement. We need to find the total distance traveled. So, because somewhere in between here, the particle might change direction, and that's why we look at our velocity number line. Notice that the velocity changes direction at 1 and 3, so you also have to compute the positions at these times because that's where it turns around. See, because 0 to 1, it's moving to the right. Then from 1 to 3, it's moving to the left. And then from 3 to 5, it's moving to the right again. So we need to compute the positions at these times as well. So if I plug in 1 into the position equation, what do you got? 1 minus 6 plus 9 minus 4, that looks like 0. And then compute the position also at 3. So if I plug in 3, what do you got? 27 minus 54 plus 27 minus 4. That's 27. That comes out to negative 4. So again, from 0 to 1, the particle traveled from negative 4 to 0. So it traveled 4 units. Now it turns around and starts going to the left. Well, it went from 0 to negative 4. Isn't that 4 units? And then now from 3 to 5, now it turns around and starts going to the right again. So if you went from negative 4 to 16, you went 20 units. So what was the total distance traveled? If you went 4 to the right, here, I'll draw a picture for you. 4 to the right, 4 to the left, and then 20 to the right. What was the total distance traveled? 28. C, find the velocity of the particle when the acceleration is 0. Well, here's the acceleration equation right here. What will make the acceleration 0? 2, right? So they want you to compute the velocity at time equal 2. So just compute v of 2. That means plug in 2 into the velocity equation. Now, we got 3 of these equations. They're all the same. If I were to plug in, I would plug into this one right here. So you got 3 times 2 minus 1, which is 1, times 2 minus 3, which is negative 1, so negative 3. So the velocity would be negative 3 when t is 2. What if I said find the speed of the particle when the acceleration is 0? Now remember, speed is the absolute value of velocity, so the answer would be positive 3. And then D, when is the particle speeding up? Well, that would be when the velocity and acceleration have the same sign. Now let's just put the answer to D here. So that's why you put the number lines one on top of the other. Now just look. Where do they have the same sign? Well, between 1 and 2, right, because they're both negative. And then from 3 to infinity, because they're both positive. So that's when the particle is speeding up. Now, this problem on the test, like I told you in class, I might make it so that you have to get these number lines by using your graphing calculator. So it's, in other words, I'm going to give you something that's unfactorable. So be ready for that, just like that problem on the homework that most of you didn't do. Okay, next, number 5. Okay, so I'm giving you a function. I want you to compute f prime of pi over 3. Now what the heck does that mean? That means compute the derivative, f prime, and then plug in pi over 3 for x. So that means you better know your trig values. Okay, well, I see a quotient here. Use the quotient rule. Low d high minus high d low all over denominator squared we go. Now, if you want to, you can just plug in pi over 3 now, or if you want to simplify it, you can. It's up to you. This one, maybe you might want to simplify it just a little bit anyway. So the first thing I notice, I see a sine x here and a sine x there. You can factor out a sine x or a negative sine x for that matter. Which one you want to do? Okay, let's do a negative sine x. If I factor out negative sine x, what's left? 1 minus cosine x, and then here's a negative sine x, so plus 1 plus cosine x, all over 1 minus cosine x quantity squared. The cosines cancel out. 1 plus 1 is 2, so you get negative 2 sine x, all over 1 minus cosine x all over squared. Okay, now here's the hard part for some of you. Plug in pi over 3. Well, sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. And I will leave the simplifying to you after that. Yes, you got to know your trig values. Can't get around it. Ouch. Okay, number 7. We had this problem several times on the homework. not sure if you guys remember. Piecewise function meeting at x equal 1. Find the values of a and b so that this function will be continuous and differentiable at x equal 1. Now, we already did continuous the last 2 chapters, right? How do you make sure this function is continuous at x equal 1? Well, if you plug in 1 into this piece and 1 into this piece, you have to have the same value so that the 2 pieces actually meet and become continuous. So plug in 1 here, you get a plus b. Plug in 1 here, you get 1. So a plus b has to equal 1. Now, in order for the function to be differentiable, in other words, no sharp point there, again, if a function is going to be smooth at a point, the left-hand slope and the right-hand slope have to be equal. So that means we have to look at its derivative. So, well, if you have a function in pieces, its derivative will be in pieces as well. So what's the derivative of that? 2ax plus b, and the derivative of this one is 3x squared. So this one will tell you the left-hand slope, this one will tell you the right-hand slope. So if I plug in 1 into here and 1 into there, you got to get the same slope. So if I plug in 1 in for x here, you get 2a plus b. And if I plug in 1 for x there, you get 3. And there you go. You got 2 equations, 2 variables. I think you guys can solve that. Just subtract them and you can solve for a already. So you can see a is 2 already. So I will leave the algebra 1 to you. Alright, number 8. Now this one always gives students trouble for some reason, but nobody asked it in class. That's because you guys didn't do it. Pay now, pay later. Okay, now, if you draw a picture, it's easier to understand what's going on in this problem. You have a cubic polynomial, it's like this, and it says it passes through the point 1, 1. Now, I have no idea what that is. Let's just put it there, 1, 1. And of course, what does that mean? I can take that point and plug it in because it's on the graph, right? And it is tangent to the line y equal 5x minus 3 when x is 0. So, here, let's just do it right here then. So, here's the tangent line. So here's the tangent line, y equal 5x minus 3 when x is 0. We don't know the y coordinate yet. Man, if I knew that y coordinate, I could also plug that point in. But we do, because this point here belongs not only to the curve, it also belongs to the tangent line right here. So if I plug in 0 into this equation, we know the y coordinate is negative 3. So that means, here's another point I could plug into this equation. Now notice that you have to find a, b, and c. Those are 3 variables, which means you need 3 equations. So I can get 2 equations by plugging these 2 points in, but I still need a 3rd equation. Well, that comes from the derivative, because the derivative tells you the slope of the tangent line. Do we know the slope of this tangent line right here? Here. Yeah, it's 5. So that means when x is 0, the slope of the tangent line is 5. So if I plug in 0 into the derivative, you should get 5 because the derivative tells you the slope. So compute the derivative, 3x squared plus 2ax plus b. Don't forget the derivative of a constant is 0 now. Okay, now let's write our 3 equations. So here's one point that we know lies on the graph. If I plug in 0 for x, the y coordinate would be negative 3. So plug in 0 for x. 0 plus 0 plus 0 plus c, that's got to equal negative 3. Hey, we just figured out what c is. See, but on the test, I don't think I'm going to use that 0 because it makes things too easy. So this is just to help you understand. Okay, here's another point on the graph. If I plug in 1 for x, the y coordinate will be 1. Okay, so let's do it. Plug in 1 for x. 1 plus a plus b plus c, that's equal to 1. And finally, the last equation, if I plug in 0 for x into the derivative, you will get 5 because that's what the slope is. So if I plug in 0 into the derivative, you get 0 plus b equals 5, and then you just solve those equations. Now, like I said, this one's easy because of the 0 here. On the test, I'm telling you right now, it's not going to be 0. It'll be 1 or 2 or negative 1 or something like that. So just be ready to solve 3 equations, 3 variables on this problem. Make sure you understand what to do in this problem, though. Okay, so the question is, here's a function with trig in it. When is the derivative less than 0? When is the derivative negative? So that means we're going to have to make a number line. So we need to take the derivative, factor it, and make a number line. But we should be good at that by now. Now, remember on the homework I told you, whenever you have a trig function to a power, never mind. I'll write it on the next step. Cosine squared x means cosine x times cosine x. Ay, that's ugly. Now, the reason why you want to write it like that is because you have to know. You got to use the product rule, right? Because it's something times something. So, derivative of the first, leave the second one alone. Now, you can go plus, leave the first one alone times the derivative of the second, but since they're both the same, why not just times it by 2? We talked about that one in class, yeah? Plus, the derivative of sine is cosine. Okay, now, how the heck do I factor this out? Well, I would factor out a negative cosine x. If you want to factor out a positive one, you can, but I'd rather have my first term positive when inside the parentheses. So if I factor out a negative cosine x, you're going to have a 2 sine x minus 1. Now we are ready for the number line. What makes this factor 0? When is cosine x equal to 0? Pi over 2 and 3 pi over 2. When is this factor 0? When is sine x equal to a half? And that would be pi over 6 and 11 pi over 6. Okay, now we are ready to test, except it's not 11 pi. Ow! It's 5 pi over 6. See, that's what happens when you do this at 6:30 in the morning. Okay, what is this? 5 pi over 6 will be 11 pi over 6. Slap your head, 11 pi over 6. Okay, what's a good number to plug in here? 0. So if I plug in 0, cosine of 0 is 1, that's positive. Sine of 0 is 0, so this is negative. So what's negative times positive times negative? Positive. And you keep on testing. I keep telling you guys got to practice this, but no, I'm just going to copy what Mr. Park wrote on the board. So you need to plug in numbers and see whether it comes out positive or negative. One thing can make your work shorter, like we talked about last time. If you plug in 0 and get positive, that means if you plug in 2 pi, you should also get positive. 0 and 2 pi should yield the same result, that's why. Okay, I will leave it up to you to fill those in. Okay, number 10. This looks like the one in the book. Okay, so y is equal to f of x plus x all over g of x plus 1. Compute the value of the derivative at x equal 1. So, first step, let's compute the derivative first. Well, I see a quotient. I'm going to use the quotient rule. So, low d high, which is f prime of x plus 1, right? F prime of x plus 1. Low d high minus high d low, so that would be g prime of x plus 0. I'm not going to write the plus 0. Right, because the derivative of 1 is 0. All over denominator squared we go. And then all you have to do now is plug in 1, and all the values are given in the beginning of the problem. So at x equal 1, the derivative is equal to, let's see, plug in 1. G of 1, if you look at the chart, is 1 plus 1. You know what, I'm just going to fill it in. You guys are going to simplify. F prime of 1 is 4, so that's 4 plus 1, minus f of 1, according to the chart, is 3. 3 plus x, in this case x is 1, and then g prime of 1 is 2. All over g of 1 is 1 plus 1, quantity squared. I will leave the simplifying to you. So that problem's easy. Just take the derivative and then look at the chart for the values. Just don't make up your own rule. Because if you don't use the quotient rule, that's a fatal error. Okay, 11. F of x is equal to secant squared x, compute f double prime of pi over 3. Now what the heck does that mean? That means you need to find the second derivative and then plug in pi over 3. So, what is secant squared x? It's secant x times secant x, which means you're going to use the product rule, because it's a product. Okay, so here we go. derivative of the first, secant x tangent x, leave the second one alone, secant x, plus, and then you're going to take the derivative of the second one, leave the first one alone, but see how it's the same thing again? They're both the same, so that's why you just put a 2 there. Or you can just put plus, and then you can say, hey, gorilla plus gorilla is 2 gorilla, whatever, Danny. Okay, now that's the first derivative. Now we got to do the second derivative. Now this 2 is a constant, so you throw it on the side like an unwanted pet. Yeah. And then, Mr. Park, I got 3 things. Did we learn how to take the derivative of 3 things for the product rule? Yes, we did. So here we go. Let's see if we remember anything. Derivative of the first, secant x tangent x. Leave the other 2 alone. Plus derivative of the second one, which is secant squared x. Leave the other 2 alone. And then derivative of the third one, which is secant x tangent x. Leave the other 2 alone. So basically you just take turns, remember? And then I guess this might be the hardest part for you. Simplify. Well, you don't really have to simplify here, but you got to know your trig values. So let's just review. You got to plug in pi over 3 here. What is secant of pi over 3? Well, what is cosine of pi over 3? It's 1/2. Flip it over, you get 2. What is tangent pi over 3? Well, duh, root 3. And just plug it in, and hopefully you can do arithmetic. All right. Hopefully we got only a few more to do. Please, 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 yes. We're almost done. In fact, one last problem. Hallelujah. 12. F of x is equal to 3x minus 4 over x squared plus 1. Find the average rate of change. Come on, we've been doing this for 2 chapters already. How do you find the average rate of change from x equal -1 to x equal 3? Well, f of 3 minus f of -1 all over 3 minus -1, right? It's simply the slope of the line that goes through 2 points. So, f of 3, plug in 3, so what are you going to get? 9 minus 4 is 5 over 9 plus 1 is 10. Reduce that to 1/2, that would be better. Minus f of -1, plug in -1. -3 minus 4 is -7 over 1 plus 1, 2. All over 3 minus -1, 3 plus 1. So I will leave the simplifying to you. Average rate of change is simply the slope of the line through the 2 points. No calculus involved. B, write the equation of the line that is normal to the curve at x equal 1. Come on, we've been writing tangent and normal lines since I don't know for how long already. So first step, when x is 1, how do you find the y coordinate? You plug it in. If you plug in 1 for x, you get 3 minus 4, -1 over 1 plus 1, which is 2, -1/2. How do you find the slope of the normal line? Well, first you got to find the slope of the tangent line by computing the derivative. Well, I see a quotient here, so you got to use the quotient rule. Low d high minus high d low all over denominator squared we go. And you don't have to simplify it, but I'm going to simplify it because you're going to need to for part C. Wait, I'm recording. I'll be done in like 5 minutes.
Okay.
Okay, so simplifying the numerator, you get 3x squared plus 3 minus 6x squared plus 8x all over x squared plus 1 squared, which is -3x squared plus 8x plus 3 all over x squared plus 1 quantity squared. And I don't like my first term positive. I'm going to factor out the negative sign, but that's just me. No, I'd rather just leave it there, Mr. Park, and make mistakes. Whatever, Danny. 3x and x, 3 and 1 minus plus. Okay, there you go. All nice and simplified and factored, okay? So, when x is 1, to compute the slope of the tangent line, you need to plug in 1 into here. So what would you get? -4 times 1 minus 3 is -2, all over 1 plus 1 squared, which is 4. That comes out to 2, doesn't it? Yeah. So that's the slope of the tangent line. So the slope of the normal line would be the negative reciprocal of that. So again, using point slope form, look how easy that is. Okay, that's the answer for B. Now here's the last one for C. For what values of x is the derivative greater than 0? Which means I need to make a number line. Here is the derivative right here. Make a number line for that. What makes the top or the bottom 0? Well, negative 1/3 and 3. And nothing makes the denominator 0, right? In fact, the denominator is always positive. Okay, so think of a number bigger than 3, like 4. If I plug it in, you get negative times positive over positive. That's negative. And how do I know they alternate like this? Because 3 comes from this power, odd power, so it's going to change. Negative 1/3 comes from this factor, odd power, so it changes. Or if you don't know, how about plug in 0 and negative 1? You're going to get the same result, unless you do bad arithmetic. And we want to know when is the derivative greater than 0, so we look, where is it plus? Right there, so the answer is between negative 1/3 and 3. So, if you're on the test, and you are going to get a problem just like this, if it doesn't factor nicely, then you probably did something wrong, but some of you don't care, you just keep barging on it through. That's fine, but just then you would have to use the quadratic formula to make the thing on a number line. Okay, now there was one problem I showed you when we talked about velocity and acceleration, but you guys forgot, because probably this problem is going to be on the test. So here, I don't know if this is the same one I gave you. Here is time versus velocity. How about I draw a graph that looks like this? Here's 2 and here's 5. Okay? So when t is 2, is the particle speeding up or slowing down? Well, at 2, since this is the graph of the velocity, so when t is 2, what can you say about the velocity and then the acceleration? Well, since, look, this point is below the x-axis, the velocity is negative. The acceleration is the derivative or the slope of the graph. What can you say about the slope of the graph right there? It's positive. So if the velocity is negative and the acceleration is positive, they have opposite signs, the particle is slowing down. Now what about at t equal 5? Is the particle speeding up or slowing down? Well, we look for the same thing. Here's 5. Go up to the graph. The velocity is positive, right? Because it's above the x-axis or the t-axis, right? The y-coordinate is positive there. The y-coordinate represents the velocity. And then what about the slope? Which is the acceleration. It's positive also. So since the velocity and acceleration have the same sign, the particle is speeding up. Okay, so be ready for all of these problems. And don't forget number 31B in the book that nobody got this year. Goodbye.